Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the overview of today's session. We will be looking into the selection sort introduction, selection sort algorithm, and example of selection sort, and the implementation of selection sort, implementation also. If you could see the previous videos, we have already covered bubble sort as well as the insertion sort. And you could find the difference between what is bubble sort and what is insertion sort and what is a selection sort. Now we are going to discuss. Yes, let us see what is a selection sort. Selection sort is used to arrange the list of elements in a particular order. You know, we all know that what is sorting. Sorting is nothing but arranging the list of elements either in ascending or descending order. Okay. The selection sort is also going to perform the same. But what is the procedure it is going to follow? In selection sort, the first element in the list is selected and it is compared repeatedly with all the remaining elements in the list. We are going to take the first element that will be taken and repeatedly checking with the list of remaining elements in the list. If any element is smaller than the selected element, right? If any element is smaller than the selected element, the first element we already selected, right? That one is smaller, that means any other element that is smaller than the first element which you have selected, then both are swapped. Both elements will be swapped, so that the first position is filled with the small element in the sorted order. Okay. After performing the swapping, you need to perform the swapping of it, right? After the element is smaller, then we need to perform the swapping. Next, we select at the second position in the list, what is the element that was present in the second position, that element we are going to take. It is compared with all the remaining elements in the list. You need to compare the remaining elements with the second position in the list. Then if the any element in the smaller element is smaller than the selected element, then both are swapped. This procedure has to be repeated until all the elements in the list are in the sorted order, right? Here mainly what we are going to do, we are going to consider the first element, we are going to take the first element that is going to be compared with the all elements. In that comparison, if you find the smallest element, then the first element and the smallest element are going to be swapped. This has to be done. And if you are going to take the next one after swapping, now we are going to take the second element in the array list and that is going to be compared with the second minimum element in the list. Now both are going to be swapped. This procedure has to be repeated until all the elements should come in the sorted order. This has to be done. Okay. Now come to the next one. The same thing that has been represented in an algorithmic way. Let us see. The selection sort algorithm is performed using the following step. Select the first element from the list, the same thing, element at first position in the list will be taken. Compare the selected element with all other elements in the list, the same thing what we have discussed in the previous introduction part. In every comparison, if any element is found smaller than the second selected element, right, then both are going to be swapped. Then repeat the same procedure with the element in the next position in the list till the entire list is sorted. This has to be done. Okay. The same process has to be repeated for the next selecting of elements with the minimum element. You need to perform the swapping until when you have to repeat this process, all the elements to be get in the sorted order. Yes. Let us take one example for this and see how this selection sort is going to work. Consider the following unsorted list. These are the elements that we are going to take: 5, 20, 10, 30, 50, 18, 5 and 45. These are the elements. The first one, in the first iteration, how it is going to check. Take the first element. This is nothing but 15 will be taken. Now, you know that the index of that one is 0. The first element which you have taken, compare with the second element. If it is greater, then we are going to perform swapping, but 15 is less than 20. We are not going to do any swapping. Next, 15 and 10 we are going to compare. Is that 10 is less than 15? So that what we are going to do? We are going to perform swapping. Next, check for 10 and 30. 10 is compared with the next element, 30. Now again 10 is smaller than 30, so that we are not going to perform any swapping. Next, compare 10 and 50. No, again 10 is the smallest element, so that we are not going to do any swapping. Now 10 and 18 are going to be checked. Yes, 10 is not less than 18, so that we are not going to do any swapping. Now you compare 10 and 5. Yes, 10 and 5, in this 5 is the smallest one, so that we are going to swap 5 and 10 are going to be swapped, right? After swapping, now compare 5 with 45. Yes, 5 is less than 45, so that we are not going for any swapping. After first iteration, this is the list where you are going to get. 5 is the smallest element in the list, that is going to be placed at the first position. Okay. Now coming to the second iteration. In the second iteration, what we need to do? We need to take the second element, that is 20. Now it has to be compared with the remaining all the elements, and which is smaller, that are going to be swapped, right? Those two things has to be swapped. Now you can see the list. What is the list you have? We will see from the second iteration. 5, 20, 15. These are the elements we have: 5, 20 and 15, and 30, 50, 18, 30, 50 and 18, then 10, 45. After first iteration, these are the elements where we have. Now, in the second iteration, what we need to do is, we need to take the second element in the list. This should be compared with the elements which where you are going to find the second smallest element. From out of this, which is the smallest element you are finding 10 is the smallest element. So that we are going to perform the swapping of these two. 10 is going to become into the 20th position, and 20 will go to that position, right? Like that way we have done, and we got 5 and 10, and then we have performed. While doing this swapping, we are going to get the element of 10 here, and 20 is moved to the next position. Okay, this has done. And next, what is the next element we have? The third element. The third element is, here is 15, right? After doing it, we are going to have 15 will be in the third position. The third element here is 15, right? That is going to be compared with the remaining elements, and 15 is the smallest element. That's why it is in the third position. Next, take the fourth element, compare with all the elements which you have. Here 18 is the smallest element, and that is going to be replaced with this element, right? While comparing, if you are going to find any smallest element, we are going to swap them. That's why you are going to get the list like this: 30, 50, 20, 18 and 45, right? And after doing this, we are going to get 18 in the fourth position, right? And the next one where you are going to have is this position where you have 50, that is going to be filled with the smallest element. Among these, the smallest element is 20, where you are going to get the element here. Okay. And then we are going to have the next element, that is 30 is going to be placed, and while comparing these three elements, right, in this position we need to get the smallest element, that is why we are going to get swapped with 30 and 50. And the last we are left with 50 and 45. These two elements are going to be compared, and 45 and 50 is going to be swapped, and we are going to get the sorted list as like this. Like this way the selection sort algorithm is going to work. Now you can see here, this is how the selection sort logic we are going to write. Okay. And we are going to take the minimum element, and based on that we are going to compare. After comparison, we are going to swap the elements. If no need of any swapping, just we are going to get the elements as it is. And for this one also the time complexity is more based on the number of elements. The best case, worst case and average case, the time complexity will take more. Okay. Let us take one small example and let us see how this logic is going to work. Okay. Take some example 2, 6, 5, 1. Okay. These are the four elements which I am going to take. Let us consider this is the array of elements where we have 0, 1, 2 and 3. Okay. This is the I value, and n minus 1 means up to here. This is representing the n minus 1 position. Yes, consider this is an array where you have I equal to 0 and n position I less than n minus 1 means this is the one where you are going to have. And min value is I. Min value is I is nothing but the 0. Now j starts from I plus 1, I is nothing but 0, 0 plus 1 is 1. 1 less than n is nothing but 4, number of elements, not n minus 1, n is nothing but the number of elements. Now it will be entering into the loop after the condition is true. A of min, what is the min value? Min value is 0 greater than A of j, j is nothing but 1. 2 is greater than 6, no, 2 is not greater than 6, that is why this will not, this change won't occur. Now again the loop will be incremented. Now j becomes how much? 2, 2 less than 4, condition true again. Now here this won't be changed, A of min is same only. If I have done any change, then min value will be changed, but here you don't find any changes, right? Now this is 2 only, 2 greater than A of j value is 2. 2 is nothing but 5, 2 greater than 5. Again condition false. Now again j will be incremented, j becomes 3, 3 less than 4, condition true again. Now A of 2 value is greater than A of 3 value. What is 3 value? Is nothing but 1. 2 greater than 1 as the condition is true. Now your min value is assigned with j. J is nothing but 3. J is nothing but 3. Right. Now this is updated. Right. Now if the loop is repeating for the next time, j becomes 4, 4 less than or equal to 4, the condition fails. It will be coming out of this loop. After coming out of the loop, now we need to perform the swapping. Temp equal to A of I. A of I value and min value, whatever is updated, these two has to be swapped. Now what you are going to get? 1, 6, 5 and 2. These are going to be swapped like this way. Okay. This is how the first iteration I have given, a first pass which I have represented. If you want to check for the remaining cases, you can do the same. You do it in the same way so that you can able to trace out how the logic is going to work. Okay. This is the implementation of selection sort. Let us see the execution part also, then we will come for the summary. Open online C compiler, my projects. Yes, this is a selection sort. Yes, same as the previous what we have discussed. The main function will be the same, only the function name we are going to change. Array declaration, reading the size of array and reading the array elements. And before sorting, what are the array elements that has to be printed, calling the selection function, and after sorting, what is the resultant sorting list that is going to be displayed. And with that, we are going to see the logic of selection sort. This is the logic where we have applied. I have shown you the tracing part also. Let us try to execute this code. Yes, suppose I have given the elements as 5 only. The number of elements are, consider the number of elements are 6. Oh, sorry. Let me execute once again, sorry. Yes, give the elements as 5, 2, 1, 3, 4 and 5. Yes, you can see here 2, 1, 3, 4, 5 are the elements. 1, 2, 3, 4, 5. These are the elements which you are going to get it in the sorted order. If you want to check with some other elements, here I have given already elements in the sorted order. Let us run this once again. Three, 2 and 1. Yes, now you can see here 6, 5, 4, 3, 2. But after sorting 2, 3, 4, 5, 6. These are the elements which you are going to get in the sorted order. Okay. This is how the selection sort is going to work. Let us see the summary of today's session. Yes. In this, we have seen about the selection sort introduction. What is selection sort? And what is the logic we are going to apply under selection sort? And we have seen about the selection sort algorithm. Then we have seen the example for selection sort. And lastly, we come across the implementation of selection sort also. Okay. These are the things where you can go ahead with the selection sort. Now you make the comparison between the bubble sort, insertion sort and the selection sort. And from this you could understand what is the best case, worst case and the average case for all these 3 sorting techniques. And from these 3 we can say all these 3 sorting techniques are not much efficient to work with the large databases or large data values. So that we are going with the new sorting techniques which will be faster or the time complexity is lesser compared with these 3 sorting techniques. Those things we are going to discuss under the further sessions. I hope you understand this selection sort, right? If you have any doubts or if you want to execute the same thing, same program and try it. If you have anything, you can post it in the comments. Thank you.